Hey guys, welcome. Yeah, so in this video, I'm going to show you how to find the Laplace transform of the function f of t is equal to e to the at. So given the function f of t equals e to the at, how do we find the Laplace transform? Well, let's start with the definition of the Laplace transform for any function. Hey guys, welcome. Yeah, so in this video, I'm going to show you how to find the Laplace transform of the function f of t equals e to the at. So let's start with the definition. Remember, for any function f of t, the Laplace transform is given by capital F of s, also denoted by L of f of t, and it's equal to the integral from 0 to infinity of e to the negative st times f of t dt. Right? Okay. So that's the Laplace transform for any function, and that's how we define it. So specifically, when the function is e to the at, then we see that L of e to the at, that is f of s for this function, e to the at, is going to equal the integral from 0 to infinity of e to the negative st times e to the at, and of course dt. Cool. And now we're going to use proper grammar on this improper integral and write limit as b goes to infinity of the integral from 0 to b. Furthermore, we're going to simplify here using exponent rules and write that what we have is the same as e to the, and it's a minus s times t, and then dt, right? Okay, cool. Now, where to from here? Well, we know how to find the antiderivative of e to the a minus s times t, right? First, though, let's require that s be greater than a. I'll explain this requirement in a second, but it's required so that this limit converges. And also, let's substitute with k for a minus s. So let's say a minus s is equal to k. Now, notice that the requirement s is greater than a is the same thing as saying that k is less than 0. So I'll just write that here. By this requirement, k has to be less than 0, right? Okay, cool. And that's what we require for the convergence of this limit. All right. Otherwise, the antiderivative of e to the kt is 1 over k times e to the kt, right? So we write that what we have is the same as limit as b goes to infinity of, and then as I just said, we're going to get 1 over k times e to the kt. For the antiderivative of e to the kt, remember I've already said a minus s is k, so our integrand is really e to the kt, right? And now we have to evaluate at 0 and b and take the difference of the value at b and the value at 0 of this quantity here before we send b to infinity, but you know that from calculus and stuff. Okay, all right. Now, so then next we can write limit is b goes to infinity of, and it's going to be e to the kb divided by k, right? And then minus e to the k times 0, e to the k times 0 divided by k, right? E to the k times 0 is e to the 0, which is 1. So this is just 1 over k in this part. Okay. And then, because b is a positive number, right? B is some positive number. And k, we said, is negative. Here we have e to a negative quantity. And so we can simplify that if we write it in the denominator. So in our next step, we can write that what we have is the same as limit as b goes to infinity of, and then it's going to be 1 over k times e to the kb. Now, the exponent on e, which is k times b, is now positive since we have put it in the denominator, right? Okay, because in the numerator, because of k being negative, we had e to a negative quantity. All right, cool. And then minus 1 over k. We'd already said this is just 1, right? Okay, cool. Now, as b goes to infinity, notice that we're going to get 1 over a very large number, because we're going to get 1 over e to the very large number, since b is going to infinity, and it's the exponent of e this time is positive, so we get 1 over a huge number, right? So this is going to converge to 0. So after we take the limit as b goes to infinity, we're just going to be left with negative 1 over k. But wait, we'd said k is a minus s. So if we substitute back, we get negative 1 over a minus s. And then multiplying the numerator and the denominator here by a negative 1, we can write that our final answer, which is the Laplace transform of e to the at, is equal to, well, we get positive 1 in the numerator, and the denominator we get s minus a, so 1 over s minus a. Yeah? Okay, cool. This concludes this video, and keep watching for more.